हेलो स्टूडेंट्स, सिंपली ट्रिक्सी चैनल के इंटरव्यू क्वेश्चन सीरीज में आपका स्वागत है। आज हम देखने वाले हैं ऑपरेटिंग सिस्टम का एक टॉपिक जिसमें मल्टी प्रोसेसर सिस्टम्स एंड मल्टी प्रोसेसर ऑपरेटिंग सिस्टम्स है। तो उसके बेसिस पे कुछ क्वेश्चंस पूछ सकते हैं, तो वो कौन से हैं। यहाँ पे मैंने कुछ क्वेश्चंस लिस्ट आउट किए हैं जो एवरेज क्वेश्चंस है, इजी भी नहीं है और हार्ड भी नहीं है। वो हम देखते हैं कि कैसे उसके आंसर्स देना है। आपको आंसर्स इसके कॉम्पैक्ट देना है एंड आपको इसके क्लियर आंसर्स देना है। लेट्स सी द फर्स्ट क्वेश्चन। तो पहला क्वेश्चन आता है, व्हाट इज मल्टी प्रोसेसर सिस्टम एंड व्हाई इट इज बेनिफिशियल। एज नेम इंडिकेट्स, तो यहाँ पे देखते हैं कि ये जो हमारा सिस्टम है मल्टी प्रोसेसर सिस्टम। ओके, तो ये होता है जिसमें मल्टीपल प्रोसेसर्स या फिर मल्टीपल सीपीयूज अटैच किए रहते हैं। सो द आंसर इज मल्टी प्रोसेसर सिस्टम इज अ कंप्यूटर विथ मल्टीपल प्रोसेसर्स। एज आई told you, instead of one processor there will be multiple processors or CPU cores which are attached in one computer system that are working together, and it is basically for the performance and efficiency increment. जो परफॉर्मेंस है आपका कंप्यूटर का, अगर एक सीपीयू से थोड़ा कम पड़ रहा है तो इससे जब हम दो सीपीयू लगाते हैं तो आपका परफॉर्मेंस बढ़ता है, क्योंकि सीपीयू आपका एक्चुअल एग्जीक्यूशन टास्क करता है, एंड दैट्स व्हाई द परफॉर्मेंस गेट्स एग्जीक्यूटेड। तो एग्जांपल है, अ सर्वर विथ मल्टीपल प्रोसेसर्स हैंडलिंग साइमल्टेनियस रिक्वेस्ट, क्योंकि आपके पास अगर 10 रिक्वेस्ट आता है और आपके पास 10 सर्वर है, दैट विल बी सॉल्व एट अ टाइम बिकॉज 10 सर्वर्स आपके 10 रिक्वेस्ट सॉल्व कर रहे हैं। सेकंड क्वेश्चन जो नॉर्मली एक्सपेक्ट करते हैं, तो व्हाट आर द टाइप्स ऑफ मल्टी प्रोसेसर सिस्टम। या तो टाइप्स आपको डिटेल में पूछेंगे या फिर जो टाइप है उसको थोड़ा सा उसका डिफरेंस बोलना है। तो क्वेश्चन ये है, डिफरेंशिएट बिटवीन सिमेट्रिक एंड असिमेट्रिक मल्टी प्रोसेसिंग। तो सिमेट्रिक का मतलब जो होता है कि एज पर द मीनिंग ऑफ सिमेट्रिक, सिमेट्रिक मीन्स इक्वल, ऑल द सीपीयूज आर ऑफ इक्वल कैपेबिलिटीज, role and responsibilities are equal, whereas asymmetric multiprocessing means the role and their configuration, responsibility, everything is different. So that is symmetric and asymmetric. तो इसका डिफरेंस पूछ सकते हैं। फर्स्ट इज n number of CPUs of equality and n number of CPUs of unequality. That is the best answer. So in SMP, that is symmetric. All processors share memory and devices equally, क्योंकि equal contribution है. In AMP, one processor manages the system. आपका एक प्रोसेसर होता है जो आपको पूरे सिस्टम को मैनेज करता है। इसको मास्टर स्लेव रिलेशनशिप बोलते हैं, बिकॉज वन सिस्टम जो है वो आपका मास्टर प्रोसेसर है, एंड अदर प्रोसेसर्स आर दी स्लेव प्रोसेसर्स और द सेकेंडरी प्रोसेसर्स। एस एम पी जनरली हमें जो देखने को मिलता है वो होता है डेस्कटॉप्स में, लैपटॉप्स में, whereas AMP is used in some embedded systems. Okay, because it is asymmetric multiprocessing system, क्योंकि वहाँ पे आपका डिवाइसेस अलग अलग है, कॉन्फ़िगरेशन अलग अलग है, सो वी हैव डिफरेंट टाइप्स ऑफ सिस्टम। Now explain, the next question is explain the concept of load balancing. तो load balancing क्या होता है? To balance the load, like मल्टी प्रोसेसर सिस्टम, दैट मीन्स लेट से हमारा क्लाउड कंप्यूटिंग सिस्टम है और कोई वेबसाइट है, ग्लोबल वेबसाइट, सो विच इज एक्सेस बाय मिलियंस ऑफ यूजर्स, एंड इफ दैट पर्टिकुलर सिस्टम is managed by multiprocessor system hardware, then what will happen, this multiprocessor system will contain n number of CPUs, and that request, arriving request, will be distributed to the respective servers. For example, we have, let's say, 10 servers and we are having the request as 1000. So 1000 divided by 10, that means 100 requests will be served by every processor, and that's why it is called as load balancing. So initially there was load on one server, now that load will be distributed amongst multiple servers. So that is the thing. Next is, this is called as load balancing. So इसका example है, web servers distributed incoming request to available processors, right? So web server means nothing but what, if you take the example of Google, so the users from worldwide executes some or other query at every fraction of seconds. So these queries are accepted by Google, and they basically create thread for each and every process, each and every user request, and that user requests are now combinedly sent to the n number of servers, okay, using the respective algorithm, but that servers or n number of CPUs. One server has again n number of CPUs. So one server itself divides its request. For example, server 1 is having the 100 requests. So it can have, let's say, 10 CPUs. So 10 into 10. So each server can hold 10 requests at a time, and that can they can perform. So in this way, this multiprocessor system actually does the job. Okay, next is what is cache coherence in multiprocessor system and how it is managed. So basically cache coherence is related to the cache memory of the processor. So in processor basically we have the memory for cache, we also have the memory for registers. In cache there are again two types, one is a global cache, one is a local cache. Okay, so if you can see here, so global cache and local ones. So whenever we are accessing the we are executing a program or a process on one using one uh, CPU in multiprocessor system. So basically this a number of CPUs, they share their memory, they use their memory, local memory, and also they share their global memory, and to achieve the or to take the benefit of cache memory, because cache memory is the temporary memory where this processor can execute the respective task. Okay, so the example is in a database system ensuring all the processors. Okay, so we can have multiple processors for the data update. So whenever the data updation is required, the same task can be divided into multiple processors. So that was the fourth question. Now the next question is fifth question. Describe Amdahl laws and its relevance. Basically, Amdahl law is the law in multiprocessor system, which basically states about the efficiency of the number of programs. So what this law states that the potential speed up of a program, okay, it is this is basically for potential speed up of the program when part of it cannot be parallelized. So that means if let's say we have normally we have the programs of some sequential instructions and of some parallel instructions. So generally parallel instructions are executed with the help of threads. So the non-thread part of the program is called as a sequential part. So if that particular part is 20%, let's say we have 10 students, 10 instructions, and out of which two instructions are sequential. So we can say that the next program, that of the same program, that means remaining 8 instructions are in threads. That instructions are spread up into the thread. So that we can classify or calculate as the maximum speed on the four core system. Okay, let's say we have 4 core, that means 4 CPUs. So it can be 5x. So if this particular program is taking 10 seconds now, so after this multi-core system it will take only 2 seconds. So that is the meaning behind this particular law. Next question is, what are the types of interconnection networks in multiprocessor systems? So there are some interconnection network because these CPUs, these processors must be attached through some hardware, through some devices. So this devices are at shared memory. Basically this is used for accessing the memory which is shared amongst the multiple processors for different processes. Then point to point and hierarchical. Shared memory is suitable for small scale systems. Okay, and this point to point hierarchical are used for the large systems. So these are the types of interconnection networks used in the multiprocessor system. The next question is explain NUMA architecture or NUMA in multiprocessor systems and its advantages. So NUMA basically stands for non-uniform memory access, as you can read. So ये क्या होता है यहाँ पे? So when we have the asymmetric system, so the memory access by each and every processor is different. So one processor, let's say it has the less type of program or process, it can access less memory. Another processor is executing video type of request or program, and it may have less cache memory or global memory, so it can access the memory which is given by global cache or from other processes, and that is called as non-uniform memory access. So that as per the request, as per the program, the different type of memory will be asked for this. A NUMA system is used in high performance computing. Basically it is used in high performance computing. Next question is, what is the role of global scheduler? Yes, the global scheduler is nothing but one program or one part of a program or part of a software, or we can say part of a kernel. So what exactly this scheduler does? Basically, scheduler simply takes the input from the ready queue, number of programs, and applying some criteria, some algorithm, it gives you one respective program for the continuation of the execution. So that algorithm basically selects one program from n number of programs or from n number of processes. So this kind of architecture is generally, this kind of global scheduler is generally used in symmetric processor, because we don't have dedicated processor over here. All the processors, if you see, are the same type of processor. All the processors are say having same role and responsibility, so there will not be any dedicated processor which is called as master processor. So that architecture is found in asymmetric multiprocessor system. But now in yeah, symmetric multiprocessor, this kind of architecture is not used. Instead, there each and every processor takes the responsibility and executes the processes. But we require a kernel intervention for this, and that kernel intervention is nothing but it simply gives the task to global scheduler. So that global scheduler will now decide on which CPU, which particular program will be executed. So the best example is in cloud data centers. Nowadays, in cloud data center, this global scheduler is used to distribute the traffic or to distribute the load of the application. Next question is differentiate between multiprocessor system and computer system. This question is very easy because if you see multiprocessor system means nothing but one system, एक ही system है जिसमें multiple CPUs है, whereas multi-computer system means we have a number of multiple computer systems. So the best example is the LAN, the computers which are created through a LAN cable, okay, in a LAN network, so are called as a multiprocessor system. So multiprocessor system shares memory and operates in a single address space because we have multiple processors here in one system itself. Whereas in a multi-computer system, we have a number of computer system. So a number of CPUs, a number of input, a number of output devices, everything in multiple or quantities. Whereas in case of multiprocessor system, we have only one input output devices and other memories and other units of the hardware. Okay, whereas in multi-computer system we have separate system, and that system is basically is nothing but LAN system in every small organization. All right, now the next question is very important and a little bit different. So this question can be asked: what are the challenges which are associated with scaling a multiprocessor system to many processes? Now first of all, try to understand the meaning behind this. So scaling का मतलब है आपको अपग्रेड करना है, नंबर ऑफ क्वांटिटीज इंक्रीज करना है. सो मल्टीपल प्रोसेसर का अगर हम क्वांटिटी इंक्रीज करते हैं, so how it is possible and कैसे पॉसिबल होता है, कैसे डायरेक्टली अटैच होता है, और देर आर सम इंटरफेस प्रॉब्लम्स, and if that problems are there, how they can be handled. So basically whenever we are attaching multiple processors in the existing system, so that processors can be attached, but as I tell you, their interface is required, because directly one system is connected with another system, one processor is connected with another processor, that doesn't work. So after connecting, के उसको कनेक्ट करने के बाद हमें उसका इंटरफेस चाहिए रहता है. सो चैलेंजेस में सबसे पहले आता है कंटेंशन फॉर शेयर्ड रिसोर्सेज, हाउ दिस रिसोर्सेज आर शेयर्ड. सो सॉल्यूशंस में आपको लिखना कि बताना है कि आपको इंटरकनेक्शन नेटवर्क एंड पैरेलल प्रोसेसिंग के एल्गोरिथम्स है. दैट्स व्हाई वी कैन extend multiple processors to the existing system. Yes. So the example is, if the example is asked, you can tell that supercomputers. Now the supercomputer is not the thing like which will be created before 15 years, and the same computer will be used nowadays also. So that doesn't happen, because supercomputer at that time was having good capability, which is nowadays given by desktop. So supercomputers में ऐसा होता है कि कभी आपका जो सीपीयू है लेस इनफ होता है, और कभी जैसे नया सीपीयू आता है, नया आर्किटेक्चर आता है, सो वी कैन इंस्टॉल नए न्यू सीपीयूज इनटू दैट. तो नए सीपीयू हम ऐड करते हैं, तो ये और ऐड करते जाते हैं एज पर न्यू कैपेबिलिटी, हायर कैपेबिलिटी का आ गया, हायर प्रोसेसिंग पावर का आ गया. सो डेफिनेटली उसको ऐड करना ही पड़ता है, सो एज टू give the best performance of the multiprocessor system. So and that is the main challenge in it. So to create to adopt the new devices without interfaces and with interfaces. So that is the main challenge to multiprocessor system. सो इतने क्वेश्चंस है आपके जो बेसिक क्वेश्चंस है ऑन मल्टी प्रोसेसर सिस्टम. So you can go through it and again and prepare for the interviews. So this if you like this video, like, share and subscribe it, uh, and stay tuned for the next interesting videos. Thank you and have a nice day.